constraints and functionality of the CNC router require some degree of consideration when preparing your digital files. In principle, the CNC router is brilliant at precise and repetitive work. The degree of sophistication of the files is quite limited, and generally speaking, you will need to think through how you will fabricate your model or object and break it into its two-dimensional component parts. When you have the geometry of your parts generated, you will then need to prepare the sheet files to fit the material and the maximum bed size of the CNC router. For the demonstration, induction and competency assessment, we will be working with a simple stackable box design. It will join together with tongue and groove like edge connections that will use the high degree of cutting accuracy to make tight friction fittings. The routing operations will also exploit the various routing or toolpathing options available and uncover the limitations of the mechanical cutting process. Once you have broken down your design into its two-dimensional component pieces, you will need to arrange them on your sheet of material. For this design, we will be using a 1200 by 1200 mm sheet of plywood that is 17 mm thick. We need to arrange the shapes onto our sheet manually within the CAD program that we use to generate the geometry. In this case, I started with a drawing of a 1200 by 1200 square and arranged the shapes within the square to optimize the material use. I need to leave sufficient space between the shapes to allow for the thickness of the cutter, as well as a bit of waste material that will help hold the sheet together while it is being cut. In this instance, I intend to use an 8 mm diameter rougher for the main cut, so I'll have two 8 mm edges on either side of a shape, plus an allowance for 4 mm of waste, leaving me with a minimum allowance between shapes of 20 mm. This is a typical allowance. Along the edges, we can make this a bit smaller, but anything less than 15 mm is problematic. Possibly the major constraint of the CNC router and any mechanical cutting is the cutting of an inside right angle. Basically, using a rotating tool, it is impossible to achieve a perfect inside right angle. Whilst all outside corners can be nice and square, inside corners will have a radius equal to the cutter being used. When we look at the toolpathing in more detail, we will discuss inside and outside shape. Basically, an outside shape is the main shape itself, and the inside shapes are the cutouts from within that shape. Rectilinear inside shapes will by and large be affected by the inside radius of the cutter tip. If you want a perfect square, you will need to manually trim out the corners after the CNC cut. Small inside shapes need to be bridged, so you need to think ahead how you will be able to sand the edges off of an inside shape. For small inside shapes of say less than 50 mm diameter, it may be better to simply route out the shape, as it will give you a cleaner and safer cut. This drawing shows the extent of cutting needed to create the shapes according to our design. For the sample file, we will only have two inside shapes, and they are sufficiently large that they can be bridged and dressed using a spindle sander. It is impossible to get full sheet recovery due to the need to have some waste board to hold the job together. In this design, we can achieve 85% material recovery, which is probably at the upper limits of what is possible with material recovery using a CNC router. We will also need to consider where we will locate the bridges when it comes time to complete the toolpathing. In this instance, we will aim for 4 bridges per shape at the corners. We will place the bridges where they can be sanded off easily. Placing bridges is done in the toolpath software. You do not draw the bridges in your CAD drawings. The issue of rounded internal corners is most problematic when making snug fitting joints. In this instance, you will need to overcut the inside corners so that there is a residual right angle at the corner. Simple overcutting can achieve this, but the corner details might seem quite open. The geometry for the overcutting is done when you are making your CAD drawing. An alternative is to create a shape for a secondary cut using a smaller diameter bit. This will achieve a neater, more closed join, but it will significantly increase your cutting time. Also note that if you intend to use a friction joint like what is shown here, you need to make the tongue slightly smaller by around 1 mm overall, otherwise the joint will be too tight. So finally, once you have set up your cutting geometry and your CAD application, you will need to export your file as a DXF format, ideally as an AutoCAD release 2007 or earlier. Also, make sure that all of the shapes are closed and ensure that there are no Z values in your file, that it is truly a two-dimensional drawing.